Good morning, good afternoon, good evening. We are back and better than ever. This is linear equations in one variable. And here we have a procedure for solving linear equations. I'm not really a big fan of procedures, but there are great strategies in here that we need to know. So I thought I would go through them one at a time. It's here for your reference if you need it, but I thought I'd give examples one at a time. For example, here it's saying if an equation contains fractions, we can multiply both sides of the equation by the lowest common denominator or least common multiple, and that'll eliminate all the fractions. Sometimes that's called clearing the fractions or clearing the fractions from the equation. Okay? Doesn't necessarily have to be the least common multiple. It can be any common multiple. Here our denominators are 3 and 5, so I'm going to multiply both sides by 15. And I like to put it over 1 just to make sure I don't mess up. 15 over 1. This cancels. And then I have 5 times 2 times x is 10x. Over, I'm not going to write it because it's just 1 times 1. So 10x over 1 is equal to 10x. And then let's see what happens here. 1 and a 3, and 10x is equal to 9. And then we have an equation that's a bit easier to handle than with the fractions. I'm not going to solve any of these, I'm just showing you the strategies. Use the distributive property to remove parentheses when necessary. So the distributive property just tells us that if we have a number being multiplied by an expression within the parentheses, we multiply everything in the parentheses by that number. So negative 2 times x would give me negative 2x. Negative 2 times negative 1 is plus 2, and that is equal to 4. Again, I'm not going to solve because we're just showing you the strategies. Combine like terms on the same side of the equal sign when possible. So I'm gonna actually add something here, like maybe there's a, I don't know, 7 plus 30 here. Well, 7 and 30 are like terms, they're both numbers, so I can make that 37 is equal to, and then the like terms that I have here are the 7x and the negative 9x. That gives me a negative 2x, and 8 has nobody to play with, so we just have the plus 8, and we have combined like terms to make this simpler. We can use the addition and subtraction property of equality to gather like terms on the same side of an equation. For example, I need my one thing that some folks say is x is on one side, everything else on the other, or variables on one side and everything else on the other. So I'm going to add 3x to both sides. 2x plus 3x gives me the 5x, and I still have plus 5. Equals, and remember a negative 3x and a positive 3x gives me 0, and 0 minus 25 is minus 25. And then I'm going to subtract 5 from both sides to get all the numbers on one side without variables. So that would leave me with 5x on the left side. Positive 5 minus 5 is 0. 5x plus 0 is 5x. Negative 25 and negative 5 is negative 30, and then we could solve. And then we have solve for the variable using division or multiplication property. This first one is real simple. We're just going to divide both sides by 5. And then we have, this becomes 1 because 5 over 5 is 1, and 1 times x is x. And negative 30 divided by 5 is negative 6. Now here, you might think, oh man, I don't want to divide by a fraction. Well, you could clear the fraction by multiplying everything by 3, or we can multiply by the reciprocal of the fraction. Multiply both sides of the equation by the reciprocal. The reciprocal of 2/3 is 3 over 2. And anytime I multiply a fraction by its reciprocal, I get 1. 3 and 3 cancel out to give me 1. 2 and 2 cancel out to give me 1. 1 times 1 over 1 times 1 is 1, and 1 times x is x. And then I just have a little bit of multiplication to do here. And for this particular equation, I get x equal to 27. So those are just some quick strategies that you need to solve equations. And we're going to use some of them to solve these, and we might get some extra interesting solutions. I picked these special. So I'm going to use the distributive property here and get 2x minus 8 plus x plus 5 is equal to 5x. Now I have a minus 2 here, so I have to remember that because the 2 times x is 2x, but with the minus there, I'm subtracting it, so it becomes minus 2x. And then 2 times 4 is 8, but again, I'm subtracting it, so that becomes minus 8. So we're going to clean everything up here. 2x combining like terms. 2x and x is 3x. Negative 8 and 5 is negative 3. 5x minus 2x is 3x minus 8. Then I'm going to get my x's on one side, so I'm going to subtract everything. Okay, and so 3x minus 3x is 0, and so I'm left with negative 3. 3x minus 3x is 0, and I'm left with negative 8. But wait a second, I have no variables left, and I have something that does not make sense. Negative 3 does not equal negative 8. So whenever that happens, you have an equation that has no solutions. No solutions. Okay. Very similar looking equation. Let's see, distributive property here, 2x plus 8. Let's see, 3 times x is 3x. We're subtracting, so that becomes minus 3x. 3 times minus 5 is negative 15, but we're subtracting, so that becomes plus 15 equals negative x plus 23. Let's clean her up here. 2x minus 3x is negative x. 8 and 15 is 23 equals negative x plus 23. Okay? And I have the exact same thing on either side of the equation. Let's think about this. Anything that I could replace x with would give me a true statement, like 1. Negative 1 plus 23 is 22. Negative 1 plus 23 is 22. How about 10? Negative 10 plus 23 is 13. Negative 10 plus 23 is 13. So in those cases, I would have gotten 22 equals 22 and 13 equals 13. If I have the exact same thing on both sides of an equation, that means there are an infinite number of solutions, because I could replace x with anything and have a true statement. Okay. All right, we're going to stop that right there, and we'll continue with proportions.